Hey everybody, welcome back to the Nidus Anarchy series. I'm your host Adam, CIO and co-founder in Nidus, and today we are going to talk about the DGX Spark, an AI supercomputer in a little teeny tiny box. So, what is the DGX Spark? All intents and purposes, it's an AI development computer that sits on your desktop, a super tiny form factor with massive compute power. Now, this was originally developed so that AI developers could build and play around with, fine-tune really large memory models that you would normally need a very large, very expensive computer to do. So things that this thing can run, before this you would need something like Nvidia's H100, which costs like $50,000, not really open to the average developer, where the DGX Spark is $4,000, $3,999.99. Sorry, not $4,000. But what you get for it is something that doesn't exist anywhere else in the market, right? Like, you're not going to spin up a little Mac Mini and throw the models on there. You're not going to put this on your computer either. So as an example, previous video, I built my AI little computer in my box, and that's got an RTX 4090 in it. With that, I can just barely run a 32 billion parameter model on it, the Qwen 2.5 coder model. That's kind of what I have it running at peak. And I can't get anything else on there. There's no way. Even with the 5090, I couldn't get a 70 billion parameter model on there. With this, I can run the Qwen 2.5 72 billion parameter model. It will load the whole thing into memory, no problem. And it can go even higher. And that's kind of where this thing goes. If you do different quantization models and stuff, it can go even bigger. So that's what this is for running much larger models, which are way smarter, can do a lot more thinking and more complex problem solving. So that's why I picked it up, because I wanted to be able to run larger, longer, more complex models and get better results out of it. And I really just wanted to play with it. Let's just be serious. This is one of those AI nerd toys that I just had to have my hands on, so I went out and picked it up. So let's talk about all the specs in this thing. And I'm gonna do a little comparison for you too, because like I said, my other box is the 4090 in there, which is a consumer graphics card that a lot of people have when they have their home AI systems. So we're gonna do a little side by side, because that's really how I wound up buying this, right? Is I have the 4090 and it's really good for what I want, but can it be better? And also, you can chain these things together. So if I were to pick up two, if I was somehow won the lotto or something, I could stack two of them, I could connect to them with a cable, and then I could run 128 billion parameter models easily on this thing. And now we're talking the new Kimi K2.5 model that just came out. So with two of these bad boys stacked together with the Kimi K2.5 open weight model, quantized down, you could really run almost the equivalent of an Opus 4.5 on your desk. That's crazy. And I mean, for $8,000, yes, that is stupid expensive, but when you think about what you're getting out of that and what it would take normally to run that model, it's an astronomical savings in cost and just form factor. You don't need a whole bunch of servers, right? You can have these little tiny boxes. So let's talk about the differences of this box versus the 4090. So in here, the main chip, the main processor that we have is the Grace Blackwell GB10 Super Chip. It's an integrated CPU and GPU. There are 6,144 CUDA cores. Conversely, on the 4090, there's 16,384 CUDA cores. We'll get into why that's important later. Tensor cores, 5th gen tensor cores. They didn't really say how many are in here. It's not published anywhere. There's 512 on the 4090. The GPU, this is where it's important. So this is 128 gigabytes of unified RAM. So it's CPU and GPU unified together. And that's how it's able to load these super large models. That's how it can fit a 72 billion parameter model into memory. Where on the 4090, it only has 24 gigabytes of VRAM. And that's where it has to load the whole model into. So that's why no matter what, you're never gonna get a 70 billion parameter model onto a 4090 graphics card, which means you cannot load those larger, more complex, deeper thought models, which is the whole reason we wanna buy this little thing. Peak AI compute, this is the next big benchmark. So on the 4090, it's not really marketed, but they're saying that it's in the tens of teraflops. So let's just say 20, 30 teraflops for the 4090. And on here, we're looking at 1 petaflop of CPU. That's crazy. A petaflop of CPU. I mean, I'm coming from the world of my first computer was a 486SX. I mean, I remember like when the 50 megahertz computers came out. I mean, we're talking petaflops of power now. It's crazy to see where we're at. So that's huge. So form factor, that's a whole nother thing too, right? So on the 4090, you have to build a whole desktop machine. You have to have the box, you got to have the motherboard, all the fun things, the hard drive. So it's even though like right now the 5090 is going for about $4,000. It's almost the same price as aftermarket. If you can find one new like Micro Center for like $3,200, good luck. They're impossible to find. But these things you can find all over the place. So this one's $4,000. Aftermarket, you can find a 5090, which is the latest and greatest graphics card that can run larger models, but it's still, you're going to pay $4,000 anyway. But then you also need the RAM, the CPU, the motherboard, the power supply, at least a 1,000-watt power supply. So it's going to cost you a lot more in the long run as well. This thing also has a 4 terabyte hard drive built into it as well. So this thing is a beast for a little tiny computer. So let's look at it. Let's look at this little tiny beast of a computer. DGX Spark. I already ripped it open, as you can see. I already popped this cherry. Here we go. The DGX Spark. You ready for this? Ooh. There it is. Huge AI supercomputer power in a little tiny little itty bitty box. This is it. This is the DG. I mean, I know I have giant hands, but still, this thing is tiny and it's really cool. I mean, honestly, this is the coolest computer I have ever bought by far. It's gold. You feel fancy. I mean, that's for sure. You definitely feel like this is a fancy computer. The fans actually blow it down here and off to the sides. On the back, we have the link cables, Ethernet jack, HDMI, 4 USB-C, power via USB-C, and then a little power button here. And other than that, that's it. We got a little pad. And I can tell you from running this thing gets hot. When you run this thing, I've had it actually stop processing because this thing hit almost 90 degrees and decided to slow itself down. So it has some serious power in there. All right, so here's our DGX Spark. What else do we get in the box? We get a cool piece of spongy cardboard. We have our quick start guide. And then we have a power cable. That's it. That's what you get for $4,000 is you get this. And this thing is awesome. But unfortunately, it's unusable for me. So here's why. I really wanted to like this thing. I mean, I really, really, really wanted to like this thing. I really wanted to use this thing, but unfortunately, it just doesn't do what I need it for. Now, if I was building models and I had to test all this stuff out, it's probably great, but I'm not. I'm using this thing for inference, and for inference, it's ungodly slow. So while its memory is massive and it can hold these huge models and it can process them, it processes them so slow that it makes it borderline unusable for what I want. What I wanted was something that I could run a local, completely air-gapped AI model to do Sonnet 4 level coding tasks and inference for developments, things I'm working on, and it's just not there. So what I did is I loaded up Qwen 3.2, a few different models. What I did is I loaded Qwen 2.5, a few different models. I put the 7B, 32B, and the 72B models on here, and then I also ran them on my local 4090. Also, this comes local with Llama CPP to run the actual models on it, and then I also ran it with Ollama just to see if there was a difference, and there is. So if you're looking to run the DGX Spark and you want to know, hey, what should I run it on, Ollama or the native Llama CPP? The answer I can already tell you is Llama CPP, but I'm going to give you the results here. So let's break down to the benchmarks that I ran on this thing. Here we go. Okay, on the Spark, running on Ollama, the 72 billion parameter model, Qwen 2.5, it got 3.42 tokens per second. That's why I couldn't use it. 3.5 tokens per second. I mean, that's like 2400 dial-up baud modem. For actual inference, to do development, to do actual things, that's an unusable level. So then I dropped it down. Like, okay, let's go down to the 32 billion. So Spark running the 32 billion on Ollama, it got 7.23 tokens per second. Okay, so let's get into the benchmarks of this thing, because that's really what it comes down to, right? Let's get into the brass tacks here. So the first thing I ran is I put the biggest model on here that I could. So I found the Qwen 2.5 70 billion parameter model, threw it on, and it soaked it right up into that 128 gig memory, no problem, and started hammering it out. But I tested it on the local Llama CPP version, which is what comes default, what is built for this box, and I found out the hard way, VLLM doesn't work on the Spark. So, I mean, I couldn't get it to work. Claude Code couldn't get it to work. Perplexity couldn't figure out how to get it to work. They all told me it wasn't going to work. I kind of gave up. So if you can figure it out, great. I couldn't, and I just moved on. Everything said it's built to run the local Llama model, so or not Llama model, but Llama CPP. So I ran it, and it works. So don't fight it. Run with that. Let's start with this. So first I ran Ollama 72 billion parameter because I was having problems like with the VLM thing, like I was saying. So I just said screw it, put Ollama on there, ran it, and got it. Ollama was running the 72 billion parameter model at 3.42 tokens per second. Think of it like a token as a small word, right? I mean, at this point, if you're interested in this video, I think pretty sure you know what a token is at this point. So 3.42 tokens per second is so slow. It's unusably slow, right? I mean, you're not going to build things, you're not going to do development, you're not going to do really any type of inference at that level for something that is going to cost you maybe just a few cents to use a frontier model publicly. So unless you have a real need to just don't care and let this thing just run and then come back with an answer, you know, that's the biggest hang up, and that's why I'm actually going to wind up no, so it just doesn't work. So let's talk about benchmarks. The first thing I did is I threw the biggest model I could at this thing, Qwen 2.5, 70 billion parameter, and it soaked it up into the 120 gig memory, no problem. I couldn't get it to run the whole VLM thing, so I just threw Ollama on there because I wanted it just to run. I wanted it to do something, and it did. And it spit out 3.42 tokens per second. So slow. So it's able to run this large model, but really slow. Unusably slow. So I said, okay, screw that, let's step down. So then I put the 32 billion parameter model on it. The 32 parameter model of Qwen 2.5 got running at 7.23 tokens per second. Okay, better, definitely better, but still kind of painful, right? So that's when I flipped. I said, okay, let's get rid of the Ollama stuff because Ollama it's going to slow everything down. Let's go right to the core. This thing was built to run the Llama CPP, and I put Qwen 2.5, 32 billion parameter model on that, ran it, and we got 9.03 tokens per second. Better. Okay, now we're getting somewhere. And now I'm thinking, okay, well, what is my 4090 running? Because I can run a 32 billion parameter model. I can run the exact same model on my 4090 that I already have. What's that thing do? So I spun it up on there. So on the 4090, using VLLM, I was able to run the Qwen 2.5 32 billion parameter model at 38.75 tokens per second. That's massive. This thing is running 5 times slower than the 4090 on inference. And unfortunately, that's what I need. I'm not building massive models where I just need to test them out and wanting to quantize big models and do things that I don't care if it takes days to run. I want answers now, and I need lots of answers. They need to iterate quickly. So it didn't work for what I wanted. I had a feeling that might happen, but I still wanted to play with it anyway because this thing is such a monster. But in the end, it doesn't work. It just doesn't do what I need it for. And everything I read online said this is for AI developers. You're not supposed to be using this for inference and la la la. I didn't listen. I bought it anyway, and I found out the hard way. I'm that guy that learns by touching the stove. That's how I know it's hot. So, it's hot. It's hot. It's hot. I cannot run inference on this thing. So I'm gonna stick with the 4090, and I'm gonna wind up returning this bad boy. But this thing was a lot of fun. I mean, it still is awesome, and for what it does. And for what it's advertised for, which is local AI and development for these large models and to be able to do stuff, it does it great. Like, I cannot load a 40 billion parameter model on my 4090. It just doesn't work. I couldn't do it. And it does do that. It does do what it's advertised for. So for what it advertises for, it does great. For what it doesn't advertise and what everyone says it's not good for, they were right. It does not do what I want. I cannot run Claude Code locally on this. I cannot run ClaudeBot locally on this. I mean, I can, but it takes a long time to get responses back, like a painfully long time. So as cool as this thing is, as it's, I mean, I want to have, I mean, I wish this thing was just an awesome supercomputer just so I could buy it because it looks so rad. But unfortunately, for $4,000, when it doesn't do the inference that I need, it's going to have to go back in the box, and it's going to have to go back to the store, because for $4,000, it doesn't do what I want. But very cool piece of hardware, very awesome for what it's specifically developed for. But if you're looking to do inference, if you're trying to run a massively smart Claude bot, or you're trying to run some really cool, completely air-gapped Claude code development server, this isn't it. This is not it. And the next thing that I'm going to have to do is find two 5090s and spend $6,000 and just go crazy, because then I believe I can run a full unquantized Kimi K2.5 1 terabyte model locally, and that would be rad. I heard and I've seen you can do it with 2 Mac Studio Pros or whatever, but they're like, that's like $20,000 in hardware. I'm not spending that kind of money. I'm not even going to spend $6,000, to be the truth, but it is fun to dream. One quick comparison that I just want to show you guys, because I also picked this up at the same time, is how this thing compares size-wise to the Mac Mini. So this is a brand new Mac Mini. I just paid $500 for this thing on Amazon, and this is the size comparison. This is great. $500, $4,000. This is nuts. But this thing, while super powerful, does completely different than this thing. But look at the size factor of this, right? Look at that. So tiny. So tiny. But yeah, so that's the difference. Just in case you're kind of curious on the form factor size, this thing was actually a lot smaller than I thought it was going to be. When I opened the box, it just totally blew my mind. And this is not sponge. It's actually very, very hard, but very cool texture. Overall, Nvidia, I think, made a really cool box. I wish they would make a really cool, actual, usable supercomputer, like a 5090 jammed into something like this, or something that we can actually use for inference, that we can put on our desktop and not need an entire giant machine. That would be rad. But in the meantime, we still have this little thing as a head unit, and this little bad boy can be the very slow but very powerful monster to process those super large language models. So if you're looking for the DGX Spark to do inference, it doesn't work. If you're looking to have a really awesome, cool little mini AI supercomputer that fits on your desk and in the palm of your hand, this will do that. But not for what I want, guys. So DGX Spark going back, that's the review for me. I learned my lesson. Don't touch the stove, it's too hot. I'll see you guys around. Later.